Welcome to the introduction to the LabVIEW platform. My name is Li Shuang. This presentation will provide an overview of the LabVIEW graphical programming platform and how you can use it in your job. In this brief presentation, we will cover a variety of topics. I will provide insight into the unique LabVIEW development environment and its capabilities, and discuss the advantages of using LabVIEW compared to traditional programming tools. Before we dive into the details of what LabVIEW is, let's start by looking at the types of applications that LabVIEW is used to create. Engineers and scientists use LabVIEW in a wide range of industries and for diverse applications that include automated test, industrial monitoring and control, embedded design, and academic teaching and research. While these applications may appear at first glance to be very different, with unique requirements and constraints, a closer inspection shows that they share many common attributes. LabVIEW can be used to develop custom software that accomplishes each of these tasks. LabVIEW is a software development platform that can program desktop PCs as well as industrial and embedded devices using a variety of approaches. Available in multiple languages and composed of a core development environment with optional add-on extensions, LabVIEW offers several distinct advantages over the traditional programming languages commonly used by engineers and scientists. Fundamentally, LabVIEW is a graphical programming language with high-level tools and configuration utilities designed specifically for test, measurement, and control applications. In contrast, in LabVIEW, you wire together graphical icons that represent functions to determine the flow of data through your program, similar to creating flowcharts. Our LabVIEW program consists of two windows, the black diagram and the front panel. The black diagram is where users develop their graphical code. LabVIEW provides all the functionality of a typical general-purpose programming language, including data types, looping structures, and event handlers. The counterpart to the black diagram is the front panel, or graphical user interface, where the user of your application can enter commands, values, and manipulate objects such as knobs and buttons to control the application. LabVIEW provides hundreds of objects for developing professional custom user interfaces. Within a LabVIEW block diagram, you define the execution of the program using a concept known as data flow. In LabVIEW, data flows from one graphical function to the next, and a function doesn't execute until all inputs have data available for processing. As a result, the order of execution depends how data flows through the wires on the diagram. Well, LabVIEW increases user productivity, and graphical code you see on a block diagram complies directly to machine code, and thus supplies the computer's processor with the same type of instructions generated by a equivalent compliant C program. Now, I've explained that LabVIEW is a graphical programming language with equivalent functionality to traditional programming languages. Let's move on to what LabVIEW can do. LabVIEW is used to acquire real-world data. LabVIEW delivers seamless connectivity with a wide range of measurement hardware. You can use LabVIEW to quickly configure and use almost any measurement device, from standalone instrument to USB data acquisition devices, motion controllers, image acquisition systems, and programmable logic controllers. To derive useful results from acquired data, you need powerful and easy-to-use signal processing and math tools. LabVIEW offers a rich library of functions that you can easily incorporate into your programs to perform inline analysis and add custom decision-making. Effective visualization and presentation of results is essential for making decisions, monitoring processes, and sharing information. LabVIEW provides many objects such as charts, 3D graphs, tables, and indicators, which you can drag and drop onto a front panel to display data and results. The ability to combine different programming models to solve a specific problem is critical in an engineer's success. In LabVIEW, you can combine graphical programming with other approaches such as configurable tools, state charts, text-based math, and simulation to help solve the problem at hand. Unlike with traditional programming tools, all of these different problem-solving approaches are native to the LabVIEW platform, providing a single environment whose abilities span the entire range of engineering and scientific application needs. The LabVIEW development environment is available for the Windows, Mac, and Linux operating systems and can develop software to run on each. However, when creating programs and applications that solve engineering problems, personal computers do not always provide the best solution. There is often a need to target different devices and embedded platforms with faster execution and better determinism and reliability. Typically, changing execution targets requires learning a new set of functions and even entirely different programming tools. For example, a program developed in Visual Studio Net will not execute on a real-time operating system. LabVIEW offers a unique alternative where you can target many different devices without the need to learn a new development environment. For example, you can create a program in LabVIEW and download it to a smartphone for applications such as handheld signal monitoring or portable data acquisition. I hope you can get some information about LabVIEW. Thank you for your attention.